Hi, everyone. We're gonna give everyone else a few minutes to hop on here. I do want to ask, are you guys able to see the presentation as well as our conference room? You can just go into the Q&A and type in yes or no, or give us a thumbs up or something, please, to let us know that you can view all of this. Go ahead and give it just one more minute for any last minute people that are going to be joining, and then we will go ahead and get started. We're going to go ahead and get started. First of all, good morning, everyone. Welcome to Abbott Furnace Company's Troubleshooting Industrial Furnace webinar. My name is Jessica Steger. I'm the marketing coordinator here, and I will be your moderator for the webinar. Today, basically what we're going to do is have a roundtable discussion on questions that were submitted when people registered. That was an option. Not everyone did it. So we have a handful of questions that we're going to go through during today's discussion. If you do have any questions about what's being discussed, or if what's being discussed initiates or prompts another question that you might have, you will see up in the left-hand corner, there's a Q&A section that you will be able to type in your question. As soon as you hit enter or submit, we will be able to view those. We'll get through the presentation. And then at the end, if we have time, we can go back and answer those questions. If not, we will send a follow-up email or a phone call in order to help you guys with answering those questions. We also have a free giveaway. If you go to LinkedIn, follow Abbott Furnace Company. All you have to do is follow the page if you aren't already. We'll go through those later on today, and the winner will be chosen at 2 o'clock and then notified. Basically, a lot of our company information, events, things like that is shared on our LinkedIn page, so it's good to stay in the know with our information. Well, I think that is it, and we're going to go ahead and get started. So I'm going to start by introducing our troubleshooting team that we have here today. We have Dean McLean with electrical. Dean has been with Abbott for over 30 years. Matt Pavlock, who is our field service manager. He's been with Abbott for about 18 years. Andy Benson, technical services. He's been here about 7 years. And Brian Smith, our applications engineer, about 9 years. Unfortunately, Dustin was not able to attend. So we have no introduction for him, but he is our technical sales manager. Okay. Just a little brief about us for those who might not be familiar. Abbott's a continuous industrial furnace manufacturer. We have over 40 years of experience designing and producing some of the industry's most reliable continuous belt furnaces. So we're going to jump right into some of the questions that we had similar topics, so we grouped them together. You'll see that here with questions 1 and 2, and then also a discussion mainly belts related. So Brian is going to go ahead and take these two in this discussion.
Good morning, everyone. Yeah, we had some numerous questions on belt life and buildup, causing some rips and tears and shortening the life of belts. Anyone that's familiar with powder metal will know that we add lubricant to the powder for compressibility. And then in the sintering stage, we have to remove that lubricant through the preheat zone in the furnace. If that lubricant is not completely flushed from the furnace by the atmosphere when it comes out of the parts, it will decompose into carbon. And as that soot or carbon gets drugged back into the higher temperature zones of the furnace, it becomes stuck on the creases between the muffle sections and anywhere there's a little bit of a hump or anywhere that there's allowed to be buildup. And as that carbon builds up, it reduces in that higher temperature heat zone. It actually forms into carbide. And then with your friction of your belt and your weight of your parts, holding that belt over that carbide, it'll eventually, it rips the belt or shreds the belt. And then you have to go in and replace it and put a new one on. Some of the things we can do to help mitigate that is, there's some delubing tools out there. One is adding a zone 0 to the front of the furnace, which you would have to have some floor space. Basically, it's just an unheated neck that we put on the front of the furnace, and then the hot atmosphere before it X's the hood and the stack, it acts as kind of a little assist to the preheat to transfer the heat from the hot gas to those parts and effectively lengthen your delube time a little bit and help flush that lubricant out of the furnace. Another assist you could use is from a bubbler or a fast unit, where we inject a little bit of water vapor or oxygen in the front there, and that oxygen reacts with the carbon vapors, it'll form CO2 and CO, and then that gas can be flushed through the hood and out the stack, as opposed to allowing the carbon to form a solid and having the buildup. Another thing that we do on the market is called a QDP. We have some pictures of those on here. What we do in a QDP is effectively fire a gas burner to create water vapor. And then that higher dew point allows the oxygen to react with the carbon and keep that in a gas form so it can be flushed out of the furnace. So I think the next slide is just kind of a schematic. There would be a picture of a zone 0 that we could just build that in any length to go on the front of the preheat box in between the hood. Again, it just allows that hot gas to transfer the heat to the cold parts, and it helps heat them up a little faster to give you a more time in the delube state. The next one here, so it didn't transfer over, is just a plumbing schematic of what a bubbler or a picture of a QDP, how the muffle layout would be, to where we need to inject that at a lower temperature. If we get up in the above 1,400 degrees, then we run the risk of decarbing your product. So we put that up close in the first half of the preheat zone, where we'll inject that water vapor to raise that dew point to allow that reaction.
Okay, thanks, Brian. The next couple questions, we're going to give those to Dean. It came in for verifying the thermocouple results. They had said that a few times a year that the wire is pulled through the work zones. They had, the first question came from that, and then we had the follow-up question from another registrant. So Dean, if you want to go ahead and.
So the individual that asked this question was more asking about if there was any kind of device that you could simply just sit on the belt that would record your temperatures as it's going through, instead of doing the way that we normally do it with the 3 thermocouples. However, at this point in time, there's nothing small enough that can withstand the heat that most sintering furnaces run at. So unfortunately, at this point in time, there is nothing that you can just simply set on the belt that would run through and record it, unless you're doing something under like 1,200 degrees. I believe they make stuff for lower than that, but a normal sintering furnace, there's nothing available for that at this time. The other question, how to adjust the length of a delube zone, other than what Brian had just talked about with adding different parts and modifying your furnace, the really only thing you can do is your thermocouple location. On the side of our furnace, we have a thermocouple block that would have 3 holes in it, and you could, just by moving your thermocouples, let's say you're working on zone 1 and zone 1's off to my left. If you would put that thermocouple in the hole closest to that zone, that's going to lengthen it, as where if you would put it in the 3rd hole back, you can change the length actually by like 6 inches just by changing the location of your thermocouple, as well as like either your 2nd or 3rd zone. You would put that control thermocouple towards the rear of that zone. That would give you the maximum distance that your delube zones would be able to effectively work at, without having to, again, add a zone 0 or QDP or anything like that.
Okay. Thanks, Dean. Another topic that came in, not specifically a question, but was on atmosphere control. So Brian went ahead and we have a couple slides here just as an overview of that. If once he does go through some things, if there was anything more specific, like I had said, go ahead and you can drop that into the Q&A section and we'd be more than happy to answer that for you.
Yeah, I'm not really sure what the question was there, but just some kind of, this slide just talks about some atmosphere related problems that you would see in your furnace that would be related to atmosphere flow. But any air or anything that enters into the furnace, if you have an air leak or a water leak, you'll see it in discoloration. Depending on the section of the furnace where the leak is taking place, you'll see different colors of your product. The first one there, frosted parts, it would just have a dull look that wouldn't be shiny. That would be occurring up toward the front of the furnace in the preheat zone. If you had a leak there, we talked briefly about adding the water vapor or an oxidant there to react with the lubricant vapors. If you had too high of a dew point in the front of the furnace, you would actually remove the carbon from the parts themselves, and that would give them that frosty look. Sooting, we talked a little bit about. Sooting on your parts may indicate that the atmosphere in the furnace is not balanced, we would say, to where we're not getting a good forward flush to remove all those carbon vapors out the front. If they were being carried back into the later part or the higher temperature parts of the furnace, that soot would condense out and kind of be on the parts. So you could see sooting as far as like a grease on the parts or staining. You may see sooting as like a black snow laying on the parts, and that would indicate more of an atmosphere balance or an atmosphere lack of flow issue. Blistering, anyone in the powder metal industry, we talk about blistering. That would be basically your parts getting too hot too fast, and you would have the lubricant inside the part would go directly from a solid to, from a solid to gas from heating up too fast, and it would burst out of the surface of the part like a little volcano, is what we talk about when we see blistering. Oxidation, talked about, depending on the zone of the furnace that we had a high oxygen or a water level, it would discolor the parts. And depending on the color of the parts, that would tell us in what area of the furnace to look at. Belt oxidation is kind of the same. If we have a higher dew point, the belts are typically a 314 stainless grade. So stainless steel is more susceptible to smaller leaks, whether it be air or water. Maybe we're seeing good product coming out of the furnace, but if we have a discolored belt, it could tell us that maybe there's a minor leak in there that may eventually get worse. Inadequate center would be more temperature related. Maybe if your belt speed's too fast or you have an issue with a zone of the furnace not holding temperature. And then we talked a little bit about decarburization. We want some oxygen in that preheat zone to react with the carbon vapors of the lubricant, but we don't want too much to where it attacks the carbon in the product, causing the decarburization. Again, the oxidation can be caused by air getting in the furnace somewhere, whether it be a leak in a welded seam or a bolted flange. It could be a bad gasket on the side cover. It could be an atmosphere issue. It could be cold air pushing down the stacks into the furnace. Could be caused by a water leak in the cooling sections. And it could be caused by carbon dioxide reacting from those lubricant vapors to where the oxygen will break apart and it'll combine and cause you some decarburization. Again, the color of the oxidation on the product will kind of pinpoint a certain area of the furnace where we would start to look for those leaks. And I think the next slide will show for some reason they didn't copy over. Sure. So there you can see some discolored product, a picture of the parts. So the gold color would indicate that we have an air leak. toward the exit end of the furnace, back toward maybe where the curtains are between the cooling zones. And the blue shade would indicate that it would be a little farther up into the cooler, maybe at the end of the high heat where it goes into the first cooler. So again, by seeing the color of the parts, if you had a leak in the high heat while you were at temperature, your parts would be black and maybe flaky and scaly. And we talked about in the front of the furnace in the preheat zone, where they would kind of have a frosted or a matte finish. They wouldn't look shiny. The picture of the parts there with the gold and the blue color, those parts should be fine as far as hardness and material. It's just a surface effect or discoloring issue. But again, that's more from a leak that would be at the exit end of the furnace through maybe the curtains being worn or air getting in the back into the furnace somewhere. So one of the tests we take a lot of phone calls on troubleshooting, and people will call and say they have a leak. One of the tests we'll have them do is a copper steel stainless test. And all we're doing there is we turn the high heat temperature down to 1900 because we don't want to melt the copper. And then we would go to a nitrogen atmosphere. We'd remove the hydrogen or the combustible gas that you're using. We'd want to do this test under strictly nitrogen. And then we would just place a piece of copper, a piece of steel, and a piece of stainless steel on the furnace, let it pass through. And if we have an air leak, the copper and the steel will oxidize. If we have a water leak, the copper will come out clean, but the steel will be oxidized. And then that kind of gives us the ability to what we have to do next. Are we chasing an air leak, or we have to look in our cooling zones for a water leak? So that's just a simple test you can do that'll point you in the direction of, are you looking for air or are you looking for water?
Actually, sorry guys, we actually already covered this. Let me see. This is pulling in. I apologize here. Okay, good. Okay, here's the sample cart, Brian.
All right, so we had a question. Somebody was asking about, they must have been seeing a high oxygen level in their humpback furnace. And kind of the last part we talked about touches on it a little bit. But we have the ability here when we go out troubleshoot, we'll bring in what you see there in the picture is an atmosphere cart where we can look at hydrogen or combustible gas, we look at oxygen, and we look at dew point. So we'll come in and we'll probe your furnace where you could purchase these to do yourself. And again, this will help you look at if you have an air leak or a water leak, you can probe the furnace and see where exactly that leak is. And then from there, you can go through the steps of troubleshooting to reduce that leak to get either the oxygen or the water or both taken care of. So we would come in, we measure both for oxygen content and for dew point, what we previously talked about with an air leak or water leak. That would come in, we would come in and do that and do the analysis, and then we would be able to fix air leaks or water leaks. If you're doing this yourself, just some quick places to start would be with the exit curtains. Make sure that your curtains aren't worn out to where they're not touching the furnace belt, or if you're running parts or fixturing that with some sharp edges, they'll actually cut through those curtains where you'll have gaps in them where air will be able to come up through the back end of that furnace. We talked a little bit about atmosphere balance and having a good flush out the front of the furnace. If we don't have enough flow to maintain positive pressure to where the pressure inside the furnace has to be higher than the pressure in the building to be able to maintain positive pressure so that we don't pull air into the furnace. So maybe if the furnace is a little bit out of balance, or if we've trimmed the flows back, trying to reduce the amount of atmosphere flow or reduce the amount of hydrogen that we flow in the atmosphere, you may be causing yourself a problem, causing a leak by letting air ingress through the front of the furnace or down through the stacks. Again, there's the things we can do with monitoring the atmosphere, the copper steel test to determine if we have an air leak or a water leak. There's some other tools we use with combustible gas sniffers. We'll come in and run those around the flanges or the side covers where there's gaskets. And those will be able to pick up any hydrogen or combustible gas that's working its way through a leak in a welded seam or a worn gasket, and be able to do that repair to reduce the air leak. And again, we can add temperature monitoring and data logging to that to do the temperature measurement as well as the atmosphere analysis. This is just a graph we did. We took one of our atmosphere carts and we tied a probe to the furnace belt and left it ride through. And you could see before we balanced the atmosphere, our hydrogen, amount of hydrogen in the atmosphere, percent of hydrogen, stayed the same from the front of the furnace all the way through the exit of the furnace. The next line in the blue is the oxygen line, where as we entered the furnace and went through, we maintained a low oxygen content. And in the bottom one is the dew point. Again, as we traveled through and got back into the higher temperature heated zones, we maintained a very low dew point through the furnace. The next slide will show after we balanced the atmosphere, our hydrogen, you can see where it went through the curtain box, where our hydrogen dropped to nearly 0%. Why we did that, or why we balanced that way, is the hydrogen needs to be in the front of the furnace while you're at temperature to maintain low oxygen and low dew point so we don't discolor the product. And the hydrogen is what reacts with those lubricant vapors to be able to flush those out of the furnace and remove them from the compacts and keep them from building up. Back in the cooling sections where the product is getting colder, we don't need hydrogen back there to react because our parts are cold enough to not oxidize. So we balance to be able to maximize the flow and to push out the front of the furnace to remove all those vapors and prevent the buildup. You can see the oxygen in the heated zones, we maintained a very low oxygen. And then it kind of went up a little bit when we went through the curtain box and into the coolers, but we still maintained it below the ppm level where we would see the discoloration and the oxidizing of the product. And again, you can see the dew point is a little bit higher at the front of the furnace with the lower temperatures where the delubing has taken place because of the hydrogen reacting with the oxygen being removed from the product. We get a little bit higher dew point. And once we get back into the heated zones, that dew point will lower to where we can get the bonding and the sintering. And then the dew point in the back of the furnace is very low because we're just using nitrogen back there as a buffer between air coming up the back of the furnace as the parts go through the cooling chambers.
That covers the handful of questions and discussion points that were submitted with registration for the webinar. Does anyone have any additional questions based off of what was discussed, or did it prompt any further discussions that you guys would like to hear about? We'll give you a couple minutes if you want to type those in. In the meantime, you'll see on the screen, we do have a handful of troubleshooting guides available on our website. You just go to abbottfurnace.com. The header, you will see resources. Once you hover over that, it will give you a drop-down menu. Just click on the troubleshooting guides. It will take you to this page here. If there's one that you are looking for, click on it, submit it. We will email that to you. If you don't see a guide here and you do have a question, you can still submit your request with whatever questions you might have, and somebody will get back to you with those. Abbott Furnace also offers, we have in the past, and we actually are going to continue to offer our continuous furnace and brazing symposiums in 2024. We will have, our first one will be in Nashville, May 7th to the 9th. The next one will be in Mexico, November 5th to the 7th. We are in the process of finalizing details on those. Registration will be coming out here within the week for the first one in Nashville. These are good to attend. We go over everything from covering brazing fundamentals to joint design to troubleshooting. It's nice if you are having an issue, you can bring those parts or whatever issue you're having, speak to someone about that. It's a little more intimate and hands-on with the process. Doesn't look like there's any additional questions coming through. So don't forget, go ahead. If you don't mind, go on LinkedIn, follow us. We will be picking a winner of our swag giveaway here at 2:00. If after you find that you do have any questions, all you have to do is email us at info@abbottfurnace.com. Do you guys have anything else? Matt?
No?
No, good. Well, everyone have a good rest of your day and thank you for attending.